Let me tell you about a severe problem in optical lenses and windows. Any material designed to be transparent reflects light. This creates blind spot blurriness and basically reduces the imaging quality of our glasses, cameras, and displays. Take, for example, autonomous vehicles. Here, the reflection from camera windows and lenses makes some crucial details of the car's surrounding disappear. Without these details, the driving algorithm can make a wrong and even dangerous decision. The traditional solution to this problem is anti-reflective films. But these films reduce the reflection of light only within a limited range of colors and angles, while in many applications we need optics for both visible spectrum in the day and infrared at night. Also, this film gets scratched, cracked, and detached easily, especially in harsh environment and physical contact. This makes them often inapplicable, for instance, in military and space optics and many other applications. The ultimate solution comes from nature. It was found that the cornea of some insects, such as moths, are covered with nanometric bumps. While being smaller than the wavelengths of light, these nanobumps produce an optical effect that prevents the reflection of light in a very wide range of colors and angles. Insects use these anti-reflective structures for night camouflage. We use them for industrial optics. I am Mark Schwarzman, co-founder of Skoros. I'm a professor of materials engineering at Ben-Gurion University and a nanotechnologist with more than 20 years of experience in academia and industry. We at Skoros have developed a unique nanotechnology to reproduce artificial anti-reflective structures on any optical surface. Our nanostructures reduce the reflection of light more efficiently than anti-reflective films. Also, since they are not made of separate materials but are etched directly within the surface, they don't detach, don't crack, even in a harsh environment. In the future, such anti-reflective structures will replace anti-reflective films in many products. That's why all the major optical companies are racing today to develop their own anti-reflective structures. But despite all efforts, this future has not yet come. Why? Well, so far the solution of these companies have three main limitations. First, they are effective only within a certain limited part of the light spectrum, while today's market demands solution for any spectral region, from visible light, for instance for displays, to infrared light for thermal imaging. Our technology is the only one that can design anti-reflective structures for any range of the spectrum. Secondly, the existing anti-reflective structures can be applied to very few materials. Our innovative technology is the only one that can produce them on any optical material. And finally, the existing anti-reflective structures are very fragile, so the surface they cover cannot be touched or cleaned using standard cleaning methods, making them inapplicable for most optical uses. Our innovative technology is the only one that produces durable structures that withstand physical contact and can be cleaned by simple and standard wet wiping. Over 7 years of R&D, we have been developing anti-reflective structures for leading Israeli companies, such as Rafael, Elbit, and MKS. We have a portfolio of proprietary IP, a unique know-how, and a highly professional and experienced team that also includes Sivan Satka, a brilliant PhD student who is deeply involved in the development and will serve as our CTO. So, what do we actually do? First, we do cutting-edge custom design of optimized anti-reflective structures for any desired applications. Then, we precisely produce them using our patented technology. Our proof of concept was demonstrated on silicon windows for infrared light, plastic lenses, and even sapphire, the strongest optical material on Earth. Sapphire is broadly used for mechanically resistant optical windows, and you find it in Rolex watches, iPhone cameras, and Apple smartwatches. But all of these have no anti-reflective coating and produce white spots and blurred images. We are the only ones that demonstrated durable anti-reflective structures on sapphire for the entire visible spectrum of light. Our business model is based on selling uniquely designed optical elements to partners as OEM for different applications. The global markets for anti-reflective coating is $5 billion. We plan to implement our unique technology in some of the most attractive and most profitable segments of these markets, targeting smartphone cameras, smartwatches, and automotive optical sensors. Tunable nanofabricated structures embedded within the material itself are the future of anti-reflective technology. We are Skoros, and we invite you to join us to unleash the potential of these structures and revolutionize the world of optics.
Greenhouse gases, mainly CO2, are driving global warming, despite global agreements signed by countries with specific commitments to lower CO2 emissions. 2021 marked a record of 36 gigaton, of which the industry emitted about 24%. Beyond the negative economic impact of CO2 emissions, the reputations of companies could be damaged to the point that they may lose market share. CO2 is emitted in numerous locations. Its reduction requires simple and affordable small-scale units that convert it to green products. The current technologies for CO2 reduction are complex, limited to specific feedstock, and require many stages and further treatment of the product. Therefore, they are not applicable to small-scale units. CarboNegev is ready to commercialize a novel technology to convert various carbon emissions, providing a compact, scalable, and affordable solution to multiple industries for decentralized units. CarboNegev offers its technology to significantly reduce the carbon footprint on site by converting CO2, solid waste, biomass, and waste gas emissions into green blending stock for transportation fuels and lubricants. The process consists of converting various feedstocks to syngas, fed into our process to produce green products at high efficiency and minimum stages. My name is Professor Moti Hershkovitz, founder and CEO of CarboNegev, with over 30 years of expertise in developing materials and processes for production of renewable fuels. Our leadership team includes Tommy Hoss, a chemical engineer, highly knowledgeable in the field, and Professor Meron Landau, our advisor and expert in catalytic materials. Over the last 8 years, $5 million were spent in the development of the patent-protected technology that can improve energy utilization while reducing CO2 emissions. Our process does not require external hydrogen. It reduces CO2 emissions by up to 99% while utilizing the energy efficiently to produce highly valuable green fuels, lubricants, and chemicals that can be used on-site or in the fuel market. The process can be operated with different feedstocks and the low area footprint in a one-screw system, making it specifically suitable for small-scale applications. The demand for liquid fuels for transportation and lubricants is forecasted to increase by 2050. The renewable fuels market potential is enormous, estimated at over $110 billion last year, and expected to increase rapidly due to government policies. Currently, the green fuels for transportation are mainly fuels from biological sources that compete with food production. Their production reached a peak because of lack of feedstock. Our feedstock is practically unlimited. It reduces the carbon footprint of the fuels by as much as 90% compared with existing fuels and can be blended with no further treatment. The benefits for industries emitting CO2 will be enormous, as they currently spend billions of dollars every year on carbon payments. Revenues will be generated from licensing the technology and operating the unit in specific projects together with renewable energy companies, and from selling green products and receiving carbon credits at multiple sites around the world. Our plants can be competitive at small scale and reach the break-even point within 5 years of plant startup. As opposed to other technologies, our technology renders the system simple and affordable, while producing superior products that can be used on-site or directly in the market with no further treatment. To date, 4 patents have been awarded and the live test run was completed at the mini pilot scale. We are currently raising $2 million to build a demonstration unit with an industrial partner within 6 months. Within 18 months, we expect to scale up our unit to be able to demonstrate our technology on an industrial scale. From there, until 2030, we are aiming to remove over 1 million tons of CO2 from various plants while producing highly valuable green fuels and chemicals. So this is the time to join us and reduce the carbon footprint for a better and greener world.
Quantum technology turns ordinary reality upside down. A cat in quantum theory can even be alive and dead at the same time. This gives rise to a disruptive technology with revolutionary implications to medicine, artificial intelligence, batteries and energy, communications, navigation, banking, and endless other fields. Quantum computers will be exponentially stronger, meaning, for example, 1 trillion times faster, opening the road to many disruptive applications such as engineering of new drugs. This is the future, but we're not there yet. We are here to enable that future. My name is Ron Folman, and I'm a professor of physics specializing for over 20 years in quantum technology. I'm the founder of 4 academic quantum centers, including a nanofabrication center for quantum chips. Now, I'm founding PhotonicsQ, to take all this know-how to the real world and make the quantum revolution a reality. The core business of PhotonicsQ is quantum chips. Just like miniaturization and integration of electronics onto chips enabled the computer revolution in the 70s, and just like the miniaturization and integration of optics enabled the communication revolution at the turn of the century, today, a new era of chips, quantum chips, are needed to enable the quantum revolution. And we, PhotonicsQ, know how to do exactly that. Together with me, our leading team includes Moti Kinslinger as CEO, bringing over 25 years of experience in the semiconductor industry, including several successful chip companies, and Itai Harel as COO. Our advisory board is made of renowned quantum scientists, technologists, and economists. But most importantly, PhotonicsQ has the required pool of experts from which to build its R&D team. In the academy, I've been training this pool of experts for the last 20 years, where $50 million were already invested in training and developing the know-how. The experts I've trained include chip design and fabrication experts, as well as experts in quantum technology. Just to give an example, these experts have recently supplied the Israeli industry with the next generation of atomic clocks and atomic magnetic sensors. The mission of PhotonicsQ is to dismantle head-on the biggest barrier standing in the way of the quantum revolution, and that is the interconnects with the quantum bits, which are called qubits, and which stand at the base of every quantum device. These interconnects are mainly made of light, so the unique quantum chips we're making are based on advanced photonics, and that's why we are called PhotonicsQ. The barrier we're tackling is enormous. While a real quantum machine requires 1 million qubits to operate, to date, the industry only has a few hundreds. The only way the industry can make the quantum leap is by integrating qubits and their interconnects on chips, just like transistors were previously integrated on chips. This is the only way the quantum revolution will materialize.
Thanks, Ron. I am Moti Kinslinger, the CEO of PhotonicsQ. My job is to take Ron's great inventions and turn them into a successful business. In addition to his extensive know-how, Professor Folman brings practical experience. He founded the world's first academic nanofabrication facility for quantum chips, which supply advanced chips to R&D labs across the world. Ron's accomplishments won world recognition, including the Lamb Medal in the US, a Miller Visiting Professorship Award in Berkeley, Falling Walls Prize in Europe, and numerous featured articles. Our competitive edge combines the expertise in both quantum circuit miniaturization and quantum photonics. This sweet spot enables us to develop highly integrated quantum chips using light for interconnect and control, which are essential building blocks in scaling up quantum computing machines. There are significant efforts in the academy and industry to develop a practical quantum computing machine. Some companies specialize in miniaturization on chip, and some specialize in quantum operation based on light. Our unique edge is the combination of these two, enabling us to introduce large-scale integration capability and become a leading provider of this critical component in the quantum market. It will take some time till quantum computers become a reality, and we will be there as a leading provider for quantum chips. In the short term, we plan to commercialize our building block circuits as components for other existing markets, such as ultra-high precision measurements, communications, and the general photonic market worth over $1 trillion. Our integrated circuits as phase stabilizer, narrow line width laser, and frequency comp will allow us to start generating revenue within a few years. We are currently in the process of raising funds and kicking off the company. We are PhotonicsQ, and we invite you to become our partner and take part in this exciting revolution of computing.
$10 million people. This is the number of people expected to die annually by 2050 due to bacterial resistance to antibiotic. Every 15 minutes, one American dies due to antibiotic-resistant bacteria. According to the research, antibiotic resistance is becoming one of the largest global threats in the 21st century. Today, many bacteria have acquired some level of resistance to antibiotics. Therefore, it is crucial to rapidly determine susceptibility to antibiotics and providing effective treatment. Why is that? Currently, it takes 48 to 72 hours, sometimes even more, to determine the type of bacteria and its resistance. Therefore, it is practically impossible to match the right antibiotic to a patient in real time. Many patients are not getting the proper antibiotic treatments, but we can do it accurately and much faster, within less than an hour. Hi, my name is Ron Linder, and I am with b-FAST.ai. b-FAST.ai develops a rapid diagnostic method that simultaneously identifies urinary bacteria and determines susceptibility to antibiotics. Did you know that 92% of the urinary bacteria, almost all of them, are already developed resistant to at least one common antibiotic? In the absence of a rapid and accurate test, physicians determine which antibiotic to prescribe based on their clinical experience. As a result, patients get the wrong antibiotic in 50% of the cases. Furthermore, 63% of the ER patients with urinary bacteria are treated with antibiotic that did not follow the clinical guidelines. This is exactly where b-FAST.ai takes the lead. Within 40 minutes, our unique technology simultaneously identifies the urinary bacteria and determines which antibiotic will be the most effective. We do so by examining the infecting bacteria using spectroscopic FTIR technique and machine learning algorithms, without the need to use any antibiotic for the test. Our patent-pending technology has been successfully developed and tested over the past 8 years and has reached an impressive proof of concept with 96% bacterial identification rate and 86 susceptibility diagnostic, all within 40 minutes. Moving forward, we expect to further improve these rates by enlarging the clinical samples, running larger datasets, and full-scale development of the algorithm. But b-FAST is not just about being fast. It is the only method that does not require antibiotic at all. It is more cost-effective, simple, and agile. Our method will enable more effective treatments, reducing rates of medical complications and hospitalization expenses. b-FAST.ai is led by our multidisciplinary team of experts. Professor Mahmoud Uliel, a leading expert in microbiology with 30 years of experience. Professor Ahmed Salman, with more than 20 years of experience in spectroscopy. Professor Isaac Lapidot, a leading scientist with more than 20 years of experience in the field of machine learning. George and Uriah, PhDs from Ben-Gurion University, our highly competent R&D and operation team. And myself, Ron Linder, with 20 years of senior managerial experience as a CEO of leading health IT and enterprise solution companies. The global market of UTI testing is estimated at $5.4 billion annually, as 150 million people are affected by urinary infection each year, with an annual growth of 11%. The market potential in the 7 leading countries, including US, top European countries, and Japan, is estimated at $1.2 billion annually. We aim to reach 5% of the market, around $60 million, within 5 years from the product launch. We develop a rapid, antibiotic-free, machine learning-based diagnostic solution, identifying within 40 minutes the type of bacteria and its resistance. Since the problem is huge, a number of startups are currently working on a rapid diagnostic system, but b-FAST.ai introduces significant advantages. We introduce the first antibiotic-free testing method, which simplifies the production of the kit as well as the testing process, making it much more scalable and agile for testing all antibiotics at once. Additionally, our method is the fastest one for both bacterial identification and antibiotic testing. Our business model is based on B2B, relying on OPEX-based SaaS model of annual subscription for number of performed tests. Our target customers are healthcare organizations, medical centers, and central laboratories in North America, Europe, and United Arab Emirates. The idea is that we grow our business together with our customers. We estimate the go-to-market plan at 36 months for software and hardware design and development, clinical trials, design partner installation, and regulatory approvals. We are raising $3 million for product design and development and clinical testing. Our vision is to substantially contribute to reducing bacterial resistance and improve the treatments. We developed the right method to do so. Together, we can make it a reality. So be fast, be right, be with us.
Imagine that you are crossing the street behind the blue car, and this happens. A simple mistake with devastating consequences. Car manufacturers try to make their cars safer using cameras, LiDAR, and radar. But all of these sensors are limited in their coverage, accuracy, and resolution. High-resolution sensing is critical for a complete perception of the scene. Moreover, most of these sensors are sensitive both to weather and lighting conditions. They also have no protection against mutual interference and cyber attacks. Our technology overcomes all of these limitations. We have built a team of leading experts from academia and industry, specializing in cutting-edge sensor technology and business. My name is Igal Bilik from Ben-Gurion University. I have over 25 years of experience in advanced sensors for automotive applications. I established and managed the sensor group at General Motors R&D, and I led the development of automotive sensing technologies. My co-founder, Professor Joseph Tabrikian, also from Ben-Gurion University, he has over 35 years of experience in radar signal processing. He is currently on 4-year sabbatical to lead our technology development. Shachar Vilval brings 10 years of experience in the automotive industry as a senior researcher at General Motors R&D. Yuval Erez is our Oazis associate. Alex Taskar and Yaron Nahari are our advisors with extensive commercial experience in fundraising and operations management. And we are currently in negotiations with a CEO who has a vast experience in leading technology companies. So, what do we do? Imagine this situation. You are driving the orange car, You can't see the scooter, which is about to charge into the road. Even the car's sensor cannot detect it due to a lack of line of sight. At the same time, the blue car can detect the scooter, but this information is not shared with you. We create a network of vehicles that share the data from their sensor to a central server in the cloud. All vehicles in the same area then receive this information. This approach provides a much more complete picture of immediate environment. Now you are alerted about the scooter and can avoid this collision. Our technology of data fusion from multiple cars solves the coverage problem and dramatically improves the sensing resolution. It overcomes poor weather and lighting conditions and immune to mutual interference and cyber attacks. In the network, the vehicles share sensor detections over cellular links. Our algorithms take this data and fuse them in the cloud to create a global view. This is possible thanks to the short latency of current cellular technology, which is way faster than the human reaction time. We will offer services not only for active safety, but also for vacant parking mapping, hazard notifications, and other big data applications. The solution is based on our patent-pending deep technology. The business opportunity is huge. We will first be targeting the US with a market of 170 million cars in urban areas. Assuming a subscription fee of $100 per year, the available market is $17 billion. With a 5% penetration, the expected annual revenue in the US alone is almost $1 billion. In the next stage, we will expand into Europe and Asia. Our business model is B2B and includes car manufacturers, fleet companies, and service providers like Waze and Park Mobile. A number of companies offer standalone cameras, radar, and LiDAR, but their coverage is limited to line of sight. Location sharing solutions have better coverage, but their resolution is low and they can detect only connected objects in the network. Our solution provides non-line of sight information on all surrounding objects with very high resolution. We already have a proof of concept demo and are preparing to run a pilot in Israel. Several leasing companies have already expressed their interest to join. After 6 months, we begin deploying our network. We will then start offering services like hazard notifications and parking. In parallel, we will engage the car manufacturers to integrate our technology. We are very excited to bring this technology to life, and we invite you to join us as we drive toward a world with zero accidents.
This is Moshe, who just a few weeks ago suffered a stroke. He uses a walker, but there is nothing wrong with his motion system. He cannot walk properly because he cannot sense his feet, and his brain has no idea where his legs are. Picture yourself spacewalking. This is how insecure he is. Moshe is not alone. Walking disabilities due to sensory impairments affect hundreds of millions of people worldwide. But current treatments treat the symptoms and not the cause. And this has not changed for nearly 70 years. We are Sensegait, and we can help these people. How? Using alternative stimulation and brain learning, we replace the missing touch and body sensation. We stimulate a healthy part of the body, and the brain learns to interpret the stimulus and use it for walking. With Sensegait, they will walk with their mind. My name is Professor Ilana Niski from the Department of Biomedical Engineering. I have 17 years of experience in neuroscience, touch technologies, and robotics at Ben-Gurion, Stanford, and Cambridge universities. My partner is Dr. Simona Bar Chaim, a neuroscientist and a serial entrepreneur with decades of experience in leading multi-center clinical trials. Together, we lead a multidisciplinary team of engineers, clinicians, neuroscientists, and designers who are all dedicated to improve the walking abilities of people in need. With funding from the Israel Innovation Authority and in partnership with b-Negev Nachalat Eran, a new rehabilitation hospital, we have the perfect ecosystem for development, clinical trials, and input from patients. We have developed a unique device designed as a belt that applies a movement stimulus on the skin while walking. Unlike other devices, our stimulus is not electric, so there is no irritation or painful feeling. The belt has one central control unit that tracks the body, recognizes the walking state, and applies the stimulus in sync with the walking. The stimulus on the skin replaces the missing sensation of the legs, and the mind connects between the walking state and the stimulus. Every person has a unique walking pattern, which made it difficult to find a suitable solution for all. In the heart of our solution is a personalized AI algorithm that recognizes the unique walking state of each person in real time. We have achieved 95% accuracy in healthy people and in people with stroke. To the best of our knowledge, we are the first to reach such success with just one unit. Our goal is for the belt to be a convenient wearable device in daily use and not just forgotten in the closet. To achieve this, our product designers work with the stroke survivors to optimize the belt anatomically and ergonomically. As a result, our patent-pending belt is a one-piece, customizable, and made from breathing, washable, sport-grade fabrics. The majority of our competitors address the motion symptoms and not the sensory cause. We have only one competitor who treats the sensory cause, but their product is bulky, and only patients who can feel their ankles can use it. We aim to reach as many patients as possible. We plan to do that through neurorehabilitation distributors that sell directly to designated clinics. At a later stage, once Sensegait gets the recognition from the rehabilitation clinics, we will offer the product to private customers as well. Our business plan includes a subscription option, where we will update the software for ongoing personalization, adding new features, and for managing specific clinicians' requests. The global market potential for our device is estimated at $1.6 billion. Our initial target market is the US, which alone represents market size of over $500 million. Based on a conservative 5% penetration rate, we can expect over $26 million sales in the US within the first 5 years. So far, we have built a standalone prototype, conducted initial clinical trials, and received Helsinki and AMAR approvals for advanced clinical trials. We will further develop our technology, miniaturize the components, and reach patient-ready design. We will also conduct advanced clinical trials with people with stroke and diabetics. To accomplish that, we are raising $2 million. It is our commitment to help Moshe to walk confidently and with a smile. Join us to make his dream a reality.